My dear student friends, I am Professor Satyanarayana, Professor at Chemical Engineering Department, JNTU College of Engineering, Anantapur, and I did my B.Tech from Osmania University, M.Tech and PhD from IIT Kanpur, and I am taking this course, that is the Master Transfer Operations, for the last 17 years. I have shared all my joy and hardships with the students regarding this course during my lectures. This course, Mass Transfer Operation, is one of the important core course in chemical engineering subject. In addition to the heat transfer and momentum transfer, the students of chemical engineering will be studying this course, and as all of you know, this mass transfer operations is the most important for the chemical engineering students, and exclusively this is the course which is studied by the chemical engineering students when compared to the other branches of engineering students. For example, when you talk about the fluid mechanics, not only the chemical engineering students, the civil engineering students also study, and when you talk about the heat transfer, both chemical and mechanical engineering students are going to study. But when you talk about a mass transfer operation, this is the course which is exclusively studied by the students. And just to talk about the mass transfer operations, the student should understand what are the applications of this mass transfer operation, where exactly the mass transfer operations are going to be used. So what I am going to do is, in the next two classes, I will be talking something about applications of a mass transfer operations, that is nothing but a separation processes, and as all of you know, the separation processes are going to play an important role in the chemical process industry, and that is 40 to 70% of the both capital and operating costs in the chemical process industry is just going towards the separation process. In some cases, 90% of the recovery of high value products from dilute solutions is going towards the separation process, and this separation process are going to find diverse range of applications, maybe living things or maybe non-living things, and because of the vast development of the chemical engineering and the separation process, this separation process are going to become, say, an interdisciplinary course. Now this separation process is going to be used for the purifying of the raw materials, recovery of the product streams, and preventing the pollution, etc. Maybe we are going to use commodity and specialty chemicals, fertilizers, biopharma, microelectronics, food processing, plastic engineering, etc. The feed rate is ranging from over a factor of 10 power 12 milligrams per hour to several million kgs per hour. The National Research Council has identified more than 50 separation process, and these separation process as of now maybe it is around 60 or so. As I have told you, the mankind may exist without any cell phone or any other thing, but the mankind cannot exist with the separation process. When you wake up in the morning till you sleep in the night, we are going to come across several of the separation process. Maybe when you want to have a tea, or when you want to have some dosa, maybe when you want to have some other things. So we need some separation process. And when you talk about the separation process, as I told you, we have a reactor and we have a reaction, a simple reactor in the chemical process industry. Surrounded by this reactor, there will be several of the separation process, maybe purifying of the raw materials, maybe we are going to get the products. As all of you know, no reaction in chemical reaction engineering is 100% conversion. So we are going to get the unreacted raw materials, we are going to get the products, we may be getting some byproducts. So there is a necessity for the separation of these byproducts from the products as well as the raw materials which are not converted. So there is a need to have some separation process here, and at the same time there may be a chances of formation of the effluent air, and so the air which is coming from the reactor, it has to go into the separation process, and we are going to get the clean air. Similarly, you may have some liquid effluents and this liquid effluents will be again going into a separation process, and there the constituents of the effluent water is removed, is separated, and we are going to get the clean water, and the remaining materials are going to be recycled. So what I want to tell you, if you talk about a simple reaction, maybe when you talk about, as all of you know, at maybe 10th class level, we have a reaction like N2 plus 3H2 that gives rise to 2 ammonia molecules, and this hydrogen or the nitrogen, whatever you get it, that may contain some amount of the inert materials. So there is need to separate that inert materials from this nitrogen and hydrogen, and so that means there is need to have a separation process. Then it goes into the reactor, and once the reaction has occurred, nitrogen plus N2 plus 3H2 gives rise to 2NH3, and there is no, it is not possible to get 100% conversion. So we are going to have some sort of a products that is nothing but ammonia. Maybe we are going to have a nitrogen and hydrogen that has to be separated. Then at the same time there is a possibility of getting a liquid effluent. There is a possibility of the gaseous effluents. So these liquid effluents and the gaseous effluents has to be separated. So that is what I want to stress again. In simple chemical process industry, the 40 to 70% of the capital cost and operating cost going towards a separation process, and 90% in some cases, as I told you, 90% is going towards getting high value products from the dilute solutions. So this separation process now is based on the principles of mass transfer operations, and this mass transfer operation is the core chemical engineering course in chemical engineering curriculum. And when you want to talk about a separation process, the separation process must be feasible both technically and economically, and this economical feasibility depends on the value of the product isolated. Maybe when you talk about two substances like sulfuric acid, maybe you talk about the gold, and when you talk about the sulfuric acid, the final product, that is nothing but sulfuric acid, which is not that it is not that important, so the cost of the product is going to be very, very cheap. And when you talk about the gold cost is very high, and the separation and the economical feasibility, you have to see what is the product that we are going to isolate it. If the concentration of the component in the raw material is increasing, the product cost is going to be increasing, and that is what we are going to have a plot like a Sherwood plot, and where this Sherwood plot we have a dilution which is in terms of ppm, and the price may be in terms of dollars per kg. As dilution is increasing, the cost is going to be increasing. Maybe you talk about mined gold, maybe you talk about vitamin B12, maybe you talk about radium, you may talk about penicillin, maybe a copper and oxygen. So the cost of the products depends finally the type of the separation technique that we are going to use, and it is also going to depend on the what are the number of components that are going to present in the mixers. So the geographical location is also one of the important thing. Maybe when we are in India, the water is very cheap, but when you go into the Gulf countries, the water is going to become very, very costly. And at the same time, if you talk about the energy costs are also very one has to be considered. The energy costs are very high in India, whereas the energy cost in the Middle East is very cheap. So the politics and environment is also going to play an important that is on the separation process. Maybe a lot of waste streams are going to be generated. The government may not have a strict environment legislations on the purification of this waste stream, and if the government is going to impose so much of restrictions, then the problem comes. We need so many separation process, and ultimately the selection of the separation process, one has to look at the economical feasibility. Then sometimes what will happen, there will be a product loss, maybe there will be a product damage. For example, when you talk about dairy industry, we have a milk and somebody wants to get a milk from the milk powder. So conventionally one can use the evaporation, and when you go for the evaporation, the problem is we have to heat the milk up to the boiling point temperature of water, that is nothing but 100 degrees centigrade. When you heat up to 100 degrees centigrade, so the protein molecules which are present in the milk, the protein molecules gets damaged, and you may not be getting a white milk powder, you will be getting a black milk powder. So and when you want to sell this black milk powder, there will not be any customers to purchase this sort of a black milk powder. So what you have to do is you have to throw it. So then what is happening, because they are using a technique called as evaporation for the separation evaporation of a milk from the milk powder, and because of this evaporation the product is getting damaged. So that is the most important thing one has to select, or maybe one has to look at what is the separation technique that we have to use for separation of a given compounds. And at the same time, when you look at the same problem of milk, getting a milk powder from the milk, so one can look at the using the same evaporation technique, but now what we are going to do, we are not going to conduct the evaporation operation at 1 atmospheric pressure. Maybe we do it at a low pressure, and maybe 450 millimeters of Hg. When you reduce the pressure to 450 millimeters of Hg, the boiling point temperature of water is going to be reduced to maybe, let's say, 64-65 degrees centigrade. So when you heat this milk powder up to 64 or 65 degrees centigrade, nothing happens to your protein molecules, and we are going to get the white milk powder. But the problem is not so simple, because maintaining the pressure is very easy, but maintaining the vacuum is very, very difficult. Even small pinholes are present in the system, the whole product gets damaged. So this is the reason people are not interested to go for the vacuum evaporation, and we have a new separation techniques like a membrane separation process, maybe like ultrafiltration. One can use the ultrafiltration process, and one can separate the milk and milk powder from the milk, and the whole operation is going to be going at room temperature, let's say 30-35 degrees centigrade. So nothing happens to your product. So the selection or the product loss and the loss damage is the most important thing, and this is the most important thing when you talk about the high value products. And frequently people are going to say the concentration, maybe people say purification, the people say fractionation, and the people say reaction mediation, but each one is having its own meaning, and one should not use the concentration, purification and fractionation as a synonyms. So generally we talk about the concentration. When you talk about the concentration, your desired component is present in a low concentration and solvent has to be removed. So we have very, very small concentration of a component, and we have very large concentration of your other impurities, and when you want to remove that solvent and from the low concentration of a components, we call it as a concentration, whereas somebody can say it is a purification if undesirable impurities have to be removed. For example, when you have the mixture of toluene and water, where the solubility of the toluene is around 420 millimeters of Hg, and when the toluene is alone, or the toluene is the pure form, it is not so irritating smell, but even when the small concentration of toluene is present in the water, so the water is irritating smell, one cannot use this water for the drinking purpose, and one has to remove that toluene, whatever it is present in the water. So there we want to remove the undesirable impurity, that is nothing but a toluene from your water. So at that time you don't call it as a concentration, we call it as a fractionation. And then another thing that we are going to talk generally is the fractionation. And here we have two components, and these two components, both components are the desired components, and each component is in a appreciable concentration. Maybe when you talk about a benzene and cyclohexane, maybe benzene concentration is 50% and cyclohexane concentration is around 50%. Then if that is the case, we don't either call it as a concentration or purification, we call it as a fractionation. And the recent thing, that is nothing but a reaction mediation, where we are not going to conduct a chemical reaction separately, then we are not going to use the separation process. So what we do here, we combine the chemical reaction along with the separation process. So when you combine the chemical reaction along with the separation process, and the reaction as well as the separation is taking place in a single unit, and continuously we are going to get the products. For example, when you talk about the ethanol production, using a fermentation process. So when you take your molasses and when you put it in your bioreactor, and when you supply your microorganism, the ethanol is going to be produced. As the concentration of ethanol is increasing in the bioreactor, then what will happen? So the product itself is inhibit your microorganism, so you are going to get a maximum yield, maybe 9% or 10%. So what one has to do, you have to stop the reaction, then you have to take out your product, and then you have to pass into the separation process, where we are going to separate the alcohol from the other materials, and then what we are going to do is we are going to get the separated alcohol, then the unreacted materials and other things recycled back into the reactor. But nowadays what is happening, we have a bioreactor which is fitted with the membrane called as a membrane, which is the operation is taking place in the form of a peroperation process, I mean a membrane process like a peroperation process we are going to use. And when alcohol is produced, we are going to have that membrane. The membrane will continuously remove your alcohol, and the alcohol comes out to the other side of the membrane, and the concentration of alcohol in the product will be very, very less. Once the concentration of alcohol in the product is going to be less, nothing will happen. There will not be any damage to your microorganism, and your microorganisms are going to sustain in the reaction medium, and the reaction is going to take place continuously. So what I want to tell you here, we are not going to use either a reactor separately or a separation process separately. We are trying to combine reactor and a separation process in a single unit. That is where the things are going to take place. And similarly, when you talk about an example like fuel cells applications, in the case of fuel cell applications, what we do, we have to conduct a reaction between the hydrogen and oxygen. This hydrogen, generally when you want to produce the energy from this fuel cell applications, one has to carry the hydrogen from the refineries, and the carrying of the hydrogen from the refineries is a very big task, because because of its flammability, there will be so much of transportation problems and other things. So when you talk about a small scale applications, and what we have to do is you have to produce your hydrogen maybe in the house itself, and that is possible by doing a methane cracking. So in the case of methane cracking, when we have a methane, when you do the cracking, we are going to get the hydrogen, and we are going to get some CO2 also, carbon dioxide also. So what we do, your product contains your hydrogen as well as the CO2. Now we are going to have the membrane. The membrane will allows only the hydrogen molecules. It will reject the CO2 molecules. Hydrogen molecules will pass out through the membrane. It comes to the other side of the membrane, and now hydrogen is there, and we can use some compressor. We can pump the oxygen, and there will be a reaction between hydrogen and the oxygen, and we are going to get the water molecule. When water molecule is going to form, then there is the liberation of the energy, that is ultimately chemical energy. That chemical energy can be converted into either mechanical energy or the electrical energy. So what we did here, we tried to integrate the reaction and the separation in a single unit. So like that, there are several applications we have where we are combining the chemical reaction and separation process in a single unit. So as I told you, there are more than 50 separation processes are reported by the National Council, and there are these separation processes are classified either per the process for the homogeneous mixtures or the process for the heterogeneous mixtures. And this process for the homogeneous mixtures or the process for the heterogeneous mixtures further classified as a rate governed separation process or the equilibrium governed separation process. And in the case of process for the homogeneous mixtures, as all of you know, where the mixture is the homogeneous solution. When the solution is the homogeneous, then that the separation process are classified. And we have a mixtures which are called as a heterogeneous mixtures, maybe like a solid and solid is mixed, or maybe a solid and liquid is mixed, maybe a solid and gas is mixed. So the mixture is not a homogeneous mixture, and the process is nothing but a heterogeneous mixture. And I am not going to discuss anything about the process for the heterogeneous mixtures in this particular course of mass transfer operation. The person who is going to deal with mechanical unit operation is going to talk about the separation of a components, or when the mixture is a heterogeneous mixture, and one can use that process for the separation of a components. And basically these further are classified into rate governed separation process or the equilibrium governed separation process. In the rate governed process is the rate is governed. There maybe we have a component 1 and we have a component 2. Each component is going to pass us through the maybe a barrier, maybe because of some other reason. So the rate is going to be controlling that. And whereas in the case of equilibrium governed separation process, when you brought two phases brought into contact, then a component is moving from one phase to the other phase. Ultimately the concentrations maybe I think by this time you know something about the chemical potential. We don't call it as the concentration, we call it as the chemical potential. So the when the chemical potentials of the component in the two phases are equal, then the system reaches to equilibrium. When the system reaches to equilibrium, that is what we call it as the equilibrium governed separation process. So we have a rate governed separation process and we have a equilibrium governed separation process. Maybe separation process are further maybe classified as contact of the two immiscible, direct contact of the two immiscible phases, and this may be a gas, maybe it is a gas liquid, maybe we have a gas solid, maybe we have a liquid, and we have a liquid solid, and we have a solid. So as all of you know, we have a gas phase, we have a liquid phase, and we have a solid phase, and there are 6 permutations are possible, and gas is highly homogeneous, and when you contact the two phases, no mass transfer is going to be occurs between the two phases, and we are not going to discuss many applications of the gas case. But whereas when you talk about the gas liquid, and we have a gas and we have a liquid, so these two are the immiscible phases. When these two are the immiscible phases, when a particular component is present either in the gas phase or the liquid phase, the component will be transferred to the other phase because of its chemical potential. And then we have a gas and solid phase. Then here we have a gas phase and we have a solid phase. Maybe many of you know from the maybe knowing at your 7th class or 8th class, when you take a camphor, when you burn it, so we are not going to get any liquid phase. Directly the solid is going to be converted into the gas phase, and this is what we call it as a sublimation process. Then we have a liquid and liquid. Maybe at the first year, maybe at your BTech first year level, we are maybe a second year level, when you are going to read the course on a physical chemistry, we are going to come across the distribution coefficient. Like this distribution comes into the picture. I have a solution. Maybe that solution is nothing but a miscible solution, where for example, when you have a system like acetic acid and water, so if I want to separate this acetic acid and water, if I can contact with the another liquid, that is nothing but a benzene, where the benzene is immiscible with the water, whereas the acetic acid is soluble in the benzene will be, acetic acid will be transferred from the water phase into the benzene phase. So that is what we call it as the liquid. Similarly, we have a liquid and solid. Then in the case of liquid and solid, and many of you know about the preparation of the tea. And in the case of the preparation of the tea, what we do is we have a tea powder. The tea powder contains the material which is required for the preparation of the tea and unwanted materials. So when you contact with the boiling water, so the material which is required to make the tea is transferred from the tea powder into the boiling water. Then we are going to get something like a decoction, and that decoction we call it as the decoction we are going to get it, and the unwanted material is going to be left out. So that is nothing but liquid solid separations, and we call it as a decoction, or maybe it is having a name called as the leaching operations. Then we have a solid and solid. So basically, when you talk about the solid and solid, maybe we have a maybe sand and rice. So when we have a sand and rice, there are two solids are there, and when you want to separate these two solids, this really doesn't come under the mass transfer operation. This comes under the mechanical unit operations, and people who talk about who are going to explain about this mechanical operation, they are going to explain about this solid separations. Then another way of classifying the separation process is what we have to do is, I have a mixer and I want to separate this mixer, and that is only possible by addition of a third component. For example, if I have a mixture of air and ammonia, maybe this air and ammonia we are going to get it from any fertilizer industry. So the air ammonia we are going to get it. The pollution control board will not allows this ammonia to be allowed into the air. So there is need to separate this air and ammonia mixture, and if suppose somebody wants to separate this air and ammonia mixture, what we can do is we can contact with the water. When you contact with the water, the ammonia now will be transferred from this air and ammonia layer into the water layer, then the air is going to be left over. So what we are trying to do is, we have a phase that is nothing but a gas phase. To this gas phase we are adding a liquid phase that is nothing but a water, right? That is the extra mass we are adding. So when you add the extra mass, now what will happen? So one of the component which is present in the gas phase, that is nothing but ammonia, the ammonia will be transferred to the water layer, and that way the separation is going to, the separation of ammonia from the air is taking place. So what we do is we are adding a extra mass. That is the reason the separation process are classified as mass separating agent. That is the absorption. That is the operation, we call it as a absorption. Similarly, we have an operation called as a adsorption. In the case of adsorption, I have a two fluids. Maybe the two fluids I can call it as a maybe like air. When you talk about air, the major components of air is nitrogen and oxygen. And for the breathing problem, for several applications, one has to separate the nitrogen and oxygen. This nitrogen and oxygen can be separated by using a technique called as a cryogenic distillation, or maybe one can talk about separation of this by using some sort of adding a adsorbent. When you add the adsorbent will have a affinity either with the nitrogen or it may be with the oxygen. So the component is going to be adsorbed and the other component will pass us through that. And maybe from 10th class, maybe intermediate, you have studied about the adsorption process. So where we have a mixture of gaseous, we have a gaseous mixtures, and we want to separate these gaseous mixtures, and we use the process called as the adsorption, where we are going to add an extra solid. When you add the extra solid, one of the component, based on the affinity, the component is going to be adsorbed and the other component will pass us through that. And there we are adding extra mass, so that is the reason we call it as the mass separating agent. And the next classification that comes under is energy separating agent. In the case of energy separating agent, we don't add any extra mass here. What we do is we add extra energy. When you add extra energy, the component, maybe a mixture contains, for example, when you talk about your fermentation product of ethanol and water, when you do your fermentation, you may be getting around 10% of ethanol. And when you get a 10% of ethanol, and for most of the applications, the ethanol concentration has to be increased, and the ethanol concentration maybe has to increase to 99.6% when you talk about the ethanol for the fuel application, or when you talk about the ethanol for the drug applications. Maybe for the drinking applications, and people like to have ethanol concentration is around 40% of ethanol. So what we are going to get it, whatever the ethanol that we are going to get it from the fermentation process, we have a 10% of ethanol, we have around 90% of water, and this concentration of ethanol has to be increased. So one of the way to increase the ethanol concentration is going for the technique called as a distillation. When you go for the technique called as a distillation, what will happens here? So we supply the energy. We have two components, that is nothing but ethanol and water. Ethanol is the more volatile component and the water is the less volatile component. And I think by this time you know about volatility. The substance which is having a higher vapor pressure, the substance which is having a higher vapor pressure at a given temperature, we call it as a more volatile substance, and other substance we call it as a less volatile substance. So in the case of water and ethanol mixture, the ethanol is the more volatile component and water is the less volatile component. And when you when I have this mixture of ethanol and water, and when I supply energy to this, now because ethanol is having a more vapor pressure or more volatility, more amount of ethanol will be vaporizing and less amount of water is vaporizing. So when you talk about the vapor phase, if you are going to see, the vapor phase contains both ethanol as well as the water, but in a different proportions. Maybe if you look at the thermodynamic calculations, if I take 10% of ethanol, maybe in the vapor phase I will be getting around 21% of ethanol. Now this that means there is a 21% of ethanol and there will be 79% of water, and whereas if you take a liquid phase, that contains around 10% of ethanol and 90% of water. This is the way when you supply energy to the system, when you supply energy to the mixer, because of the volatility, vapor is going to be generated. The vapor will have a substances, whatever it is present in the liquid, but it in a different proportions. So when it is present in a different proportions, that way the separation is going to take place. So what we do here, we are adding extra energy to the system. When you add extra energy to the system, the vaporization is taking place. So now just to continue with the same story of ethanol and water mixer, that 21% of ethanol is not sufficient sufficient. Somebody wants to use it for the drinking purpose. So what one has to do, we have to increase the further concentration. So what we do is we take that vapor phase. The vapor phase contains 21% of alcohol, maybe 79% of water, and we condense it. And when you condense it, it will become liquid. Again we heat it. When you supply energy or when you heat it, now again we are going to get the vapor phase, and this vapor phase will contain more amount of ethanol when compared to the liquid phase. Maybe 30%, maybe 30% of ethanol, maybe 70% of water. And this, even if this 30% and 70% is not sufficient, again you condense it, again you supply the energy. And this way you may get around 40% of alcohol and 60% of water, and maybe that 40% is good for the, people to satisfy their desire that 40% of alcohol is sufficient. So you can stop the process of distillation and you can use it for the drinking purpose. And there what we do is we supply the extra energy. When you supply the extra energy, the separation is going to take place. Similarly, when you talk about your mechanical operation, whatever that you call it as the evaporation, and for example, we talk about the sodium chloride and water. We have a mixture of sodium chloride and water, and now when you supply energy to this, the sodium chloride is the less volatile substance, non-volatile substance, whereas the water is a volatile substance. I think all of you know by this time what is a non-volatile. At a given temperature, or maybe at room temperature, if the substance is having no vapor pressure at all, or maybe the vapor pressure is very, very negligible, then the substance is called as a non-volatile substance, and other substances we call it as a volatile substance. So in the case of sodium chloride water system, and you talk about a room temperature of 30 degrees centigrade, the vapor pressure of sodium chloride may be in terms of 0.00 millimeters of Hg, whereas the water vapor pressure may be something like 40-50 millimeters of Hg. So when you talk about sodium chloride and water, and the vapor pressures are very, very low, and when you supply energy to this, the sodium chloride will not evaporate, whereas the water will evaporate. So when you talk about the vapor phase basically contains the water. There is no sodium chloride. So that way the separation of water and sodium chloride, we are doing it, and this is the well-known example for everybody. From the, maybe we have studied the same thing in the 5th class, maybe studied in the 6th class. Maybe when you want to get a salt from the seawater, this is the technique generally people they use it. That is what we call it as the natural evaporation. So in the case of evaporation, we have a mixture of water and sodium chloride, and we want to separate this mixture of water and sodium chloride. What we did is we supplied energy. When you supply the energy, the water is evaporating, whereas the sodium chloride is not evaporating. This is where the separation is going to take place. So those are called as the energy separating agent. Then we have another way of separating the things is a barrier separating agent. This is what I told you already about the ultrafiltration. Maybe nowadays everybody knows about reverse osmosis process. The reverse osmosis process is a well-known process. Every day we are drinking a mineral water. The mineral water, whatever the mineral water what we talk about, this mineral water we are going to get it by using the technique called as the reverse osmosis process. So in the case of reverse osmosis process, or in the case of ultrafiltration process, what we do is we have a barrier. And when we have the barrier, you have the solution like water and impurities. When you put this barrier, the water will pass through the barrier, whereas the impurities will not. Maybe low molecular weight substances like sodium chloride, potassium chloride, other substances will not pass through the barrier. So we are going to get the pure water. So this is what we call it as a barrier separating agent. So there are different ways of classifying the mass transfer operations, or there is the different ways of classifying the separation process. That is what I told you. Process for the homogeneous mixers, that is what we are going to study in this particular course, and the process for the heterogeneous mixers, this is what we are going to study in the mechanical operations course. And maybe another way of classifying the mass transfer operation or the separation process is the direct contact of the two immiscible phases. Or another way of classifying the separation process is the type of the separating agent that we use it. So based on this, there are several separation processes. I have not listed out all the separation processes. The separation processes are classified, as I told you, process for the homogeneous mixers, process for the heterogeneous mixers. Under the process for the homogeneous mixers, we have a equilibrium governed separation process, we have a rate governed separation process. Similarly, in the cases for the process for the homogeneous mixers, we have a equilibrium governed separation process and we have a rate governed separation process. In the case of heterogeneous mixers, as I told you, equilibrium governed separation process, leaching. This is what I told you when you talk about the decoction, or when you want to have a tea. and similarly we have a drying. So in the case of suppose if solid contains some amount of moisture, and if you want to remove this moisture, that is possible by exposing to the dry gas. And when you expose to the dry gas, the moisture now will be transferring from the solid phase into the gas phase. So you are going to get the dried material. That is what one example what we can see when you cut the wood from tree that contains lot of moisture, and immediately we cannot use this wood maybe for making of your furniture, maybe making of your doors and other things. So what we have to do, we have to keep it in a natural drying. In the case of natural drying, the moisture is present in the interiors of your solid, and when air is blowing over that, the concentration of the water in the air is less, so the water will pass us from the solid phase into the gas phase. So that operation we call it as a drying process. Then when you talk about the rate governed separation process, we have a barrier separation process. In the case of barrier separation process, you have a mechanical filtration, we have a centrifugal filtration, and we have a screening operations. So when I have the mixture of solids, when I want to separate this mixture of solids, which are differing in the size. So when it is differing in the size, we can use the set of sieves. When you use the set of sieves, a smaller size particle will pass us through the sieve, and the larger size particles will be retained on the sieve. So this is again a barrier. We are using a barrier like a mechanical sieve. Because of that, the separation is going to take place. Or we have a field separation process. In the case of field separation process, it may be electrostatic precipitation, or it may be magnetic separation, or it may be sedimentation, it may be flotation, and it may be cyclone separation. So all these separation processes are discussed in the mechanical operation, whereas in the case of mass transfer 1 and 2, maybe that is what we are going to study in the third year second semester. In the third year first semester we are going to study about the drying process. In the third year second semester we are going to study about the leaching process. So here we have a process for homogeneous mixes. That is what I told you. The solution is homogeneous. The solution is homogeneous. Mean again we have a equilibrium governed separation process. We have a distillation. This is what I told you. When I want to separate ethanol and water mixture, I can use the technique called as distillation. Liquid extraction, that is what I told you. When I have a mixture of two components which are miscible, we can contact with the another solvent which is immiscible with one of the component that is present in the original liquid mixture, and this whatever the component that we add, that component will have affinity with one of the component that is present in the original liquid. Now that original liquid liquid is going to be transferred here, the separation is going to take place. Absorption, this is what I told you, a separation of a mixture of gases by contacting with the liquid solvent. That is nothing but a separation of air and ammonia by contacting with the water. Then we have a stripping. Opposite of absorption is the stripping. Opposite of absorption is stripping, nothing but. So now the water is there, ammonia is there. Now if I want to use this separation of this water and ammonia, and maybe I can use some separation technique like instead of going for a different separation technique, I can go for a technique called as stripping, where what we do, we add a gas phase. When you add the gas phase, the ammonia now will be transferred into the gas phase. The water will not be transferred into the gas phase. That way the separation is going to take place, and this process we call it as the stripping process. Then we have a adsorption. This is what I told you. When I have the fluid mixers, it may be liquid and liquid, or it may be gas and gas. That is what I told you. Example is given already to you. That is nothing but air, and that air contains nitrogen and oxygen. And when I want to separate this nitrogen and oxygen, we use the technique called as adsorption. You take a solid adsorbent, and when you take a solid adsorbent, the nitrogen is having affinity, and maybe that solid adsorbent is having affinity with the nitrogen, whereas the adsorbent doesn't have affinity with the oxygen. The separation is going to take place. So we have a technique called as the ion exchange process. Maybe we have a evaporation. This is what I told you already, and this is a very interesting application again, is a crystallization. So the crystallization, if I have the solution, and if I want to get the solute, solution consists of a solute as well as the solvent. And now if I want to separate the solute from the solvent, and what we do is either we can change the temperature. When you change the temperature, the solubility of the solute in the solvent is going to changes. Because of that, there may be formation of the solid molecules. This is what an example for the separation of a sodium chloride and water. So when you want to get a pure crystals, pure crystals of sodium chloride, we cannot use the technique called as evaporation. We have to go for the technique like a crystallization. In the case of crystallization, you reduce the temperature. When you reduce the temperature, what will happen? The solubility of the sodium chloride in the water is going to decreases. When the solubility of sodium chloride in the water is going to decreases, the sodium chloride is going to be precipitated, and this is what we call it as the crystallization. This comes under the process for the homogeneous mixers and equilibrium governed separation process. And very interesting application for the homogeneous mixers, that is the barrier separation process. In the case of barrier separation process, we have a gas permeation, we have a reverse osmosis, we have ultrafiltration, we have a peroperation, we have electrodialysis, and we have a screening. Out of all these separation process, the first 5 separation process, we call it as a naval separation process, where we use the barrier, where the barrier is nothing but a barrier is not a simple barrier. The barrier what we use is a type of polymer that we are going to use, and that is what we call it as a membrane separation process. So these are the novel separation techniques. People now, many of the industries, they are using as a novel separation process, and the conventional separation technique like all this distillation, liquid extraction, these are the replaced with this barrier separation process. Then we have again a field separation process, maybe a thermal diffusion, maybe a pressure diffusion, maybe a gas centrifugation, and ultracentrifugation. So all these separation processes are classified, as I told you, either for the process for the homogeneous mixers or the process for the heterogeneous mixers. And in the brackets, if you are going to see MSA, where M stands for the mass, and BSA, B stands for the barrier, and there is a E stands for the energy separating agent. So it may be process for the classification may be based on the process for the homogeneous or the heterogeneous mixers, or the separation process may be classified based on the type of the separating agent that we use. Right. Now, if you have understood the importance of the separation process, and as I told you already, maybe one can live without a cell phone, but one cannot live without a separation process. And particularly nowadays, we are going to see everybody wants to have a mineral water. And when you talk about the mineral water, the mineral water, we are going to get the mineral water by using some separation process. Maybe everybody wants to take a tea. The tea we are going to get from the by using as a drying process, leaching process. So when somebody wants to separate the food materials, then we have to have some separation process. So the separation process are going to play again an important role in the chemical process industry, and almost all industries, they use a separation process. Maybe, for example, when you talk about our artificial lung process, and your lungs are not working properly, then oxygen absorption will not be good. When the oxygen absorption is not good, then you will be having a lot of problems. So to avoid this problem, what we do is we are going to provide the artificial lungs, and the objective of this artificial lungs, it will absorb the oxygen, then it will release the carbon dioxide. So when oxygen is absorbed and carbon dioxide is dissolved, if this artificial lung is not going to be there, then the patient will have a lot of problems. So this separation process not only going to be applicable food industry, biotech industry, chemical industry, the separation process are going to play an important role in the human applications, right? So because as the number of applications for the separation process is increasing, there are significant efforts has been made in developing a knowledge base and innovations needed for the design of a low-cost separation systems. And when you talk about this millennium challenges, what we want to have a higher productivity in current applications. I want to get a high product with existing things, and the development of new concepts and equipments. And when you talk about the higher product in the current applications, I would like to share you one of the important concepts like a process intensification. Intensifying the process. Intensifying the process means getting a higher product at a lower energy requirement and a lower space requirement. And it is so easy to understand if I give you an example like development of a laptop computer. And if you see the laptop computer, the size of the laptop computer today, it is very small. But 20 years back, if you are going to see the size of the computer, that is what people say a supercomputer. The size of the supercomputer is very, very big. it will occupy a lot of space, and it needs a lot of energy, and we have to provide a lot of air conditioning and all those things. So whatever the supercomputer is doing today, we are able to do it with the laptop computer. So that is what we call it as the process intensification, intensifying the process, that is getting higher productivity, productivity in a current application at a lower energy requirement and a lower space requirement. So when you talk about separation process also, everybody wants to have a process intensification. Everybody wants to have a process intensification. One example I would like to share with you, a Japanese company, they have developed a small fuel cell, and that will provide around 1 kilowatt hour power, and this 1 kilowatt hour power is sufficient for a family consists of 3 to 4 people. What they did, they have taken, as I told you already, they have taken the methane on one side, and the methane cracking is taking place, and they kept a hydrogen permeable membranes. And when you have hydrogen permeable membranes, whatever the hydrogen that is formed, that will pass through the membrane, and the other side we have a nitrogen, oxygen. The reaction between hydrogen and oxygen is going to take place, water molecule is going to form. So this Japanese company, they have developed a small fuel cell, and that will give you around 1 kilowatt hour power, and that will be enough for a family consists of 3 to 4 people. And that is what we are going to get a higher productivity in the current application at a lower space requirement and a lower energy requirement. And you should not be too surprised to have a maybe a BTech in process intensification maybe 15 years later now. And there the course will be highly interdisciplinary. It will consist of a chemical engineering domain, it will consist of electronics, it will consist of a computer science, it will consist of several other things. So process intensification is the domain of all the engineering areas, and being a young engineer, you have to look at this process intensification area. So your objective is to getting the higher productivity in the current applications. Then there are a lot of the things are happening, there are a lot of developments are taking place, new concepts are taking place, and the equipments are taking place. And as all of you know, AICHE, American Institute of Chemical Engineers, every year this AICHE is conducting a meeting on separation process to formulate some objectives to achieve these objectives, maybe 10 years, maybe 20 years. So there is some mission and vision of this AICHE separation division. And now the forces which are impacting the separation process are intense global competition, stringent environmental regulations, increasing raw materials and energy costs, customer demand for the better quality control, need for safe and flexible operating plants, and the cost is not only the factor, time is also the important thing. So there is a mantra called as the better, cheaper, and the faster. So as all of you know, the competition, the world is becoming a global village. There are so many companies maybe producing same product, and there is intense global competition is there. When we have this intense global competition, and the separation process are going to play an important role to meet this intense global competition. For example, when you talk about a simple example of mineral water, maybe somebody is going to sell this mineral water 20 liters for 20 rupees, maybe somebody sell the 20 liters maybe 10 rupees, maybe 20 liters 60 rupees, 20 liters 100 rupees. The quality is the important thing. So because so many companies are there, there will be so much of competition among these companies. So what we have to have some technology, and the technology is nothing but a separation process where the good quality water you should produce at a lower prices, and stringent environmental regulations. As I told you, the government is imposing a lot of restrictions to prevent the pollution problems and to maintain the earth as it is. So the stringent environmental regulations, and when you want to have this, when somebody wants to maintain these environmental issues, the separation process are going to play an important role. So to share with you, I think many of you know about pulp and paper industry. So when you talk about this pulp and paper industry, we have a wood, that wood contains of cellulose as well as the lignin. And now this cellulose is used for the preparation of the paper, whereas the cellulose is the unwanted material. And in the pulp and paper industry, what they do is to separate the cellulose and lignin, we use some alkalis. And that's alkalis may be sodium hydroxide, sodium sulfate, a mixture of sodium hydroxide and sodium sulfate. When you add this sodium hydroxide and sodium sulfate, your what do you call it, lignin is soluble in the alkalis, whereas the cellulose is not soluble in the alkalis. So what we can do is, we have the wood, by addition of the alkalis, we can separate into two portions. One we call it as the cellulose portion, other one we call it as the lignin portion. The lignin, it is not a pure lignin. The lignin contains the other materials like alkalis. So what you have to do, now you have to take this material and we will pass into the what do you call it, this lignin and alkali materials will contain the black in color. We call it as a black liquor, and this separation of the black liquor is the most important issue, because it contains alkali materials. This cannot be thrown into the flowing rivers. If you are throwing into the flowing rivers, the BOD, the COD is going to be increasing. So the small scale industries, they try to find some excuses to throw this black liquor into the flowing rivers, but whereas the large scale industries, they cannot throw it. At the same time, we have that alkali, which is important inorganics, and the separation of these inorganics are very, very important, and the large scale industries cannot throw this black liquor into the flowing rivers. And conventionally what people are using, technique called as a evaporation, then incineration. We have a water pollution problem. To prevent this water pollution problem, people are using evaporation. When you do this evaporation, the black liquor contains around 35% of the solids and 65% of the liquids. That is nothing but a water. So this 65% of water will be evaporated, and 35% like your sodium hydroxide, sodium sulfate and lignin will come out from the evaporator. That will be passed into the incinerator. Incinerator is nothing but the burner. When you pass into the burner, when you supply the energy, the boiling point temperature of lignin is around 400 degrees centigrade, whereas the sodium hydroxide and sodium sulfate is around 1000 degrees centigrade. So when you pass into the incinerator, your sodium hydroxide, sodium sulfate will not burn, whereas your lignin is going to burn. So this lignin is going to be burned, and lignin ashes are going to be converted. So this lignin ashes are going to be liberated into the air. And we want to prevent the water pollution problem by using of evaporation technique and by using of what do you call it as incineration technique. We are converting a water pollution problem into the air pollution problem, and at the same time we are losing the important material like lignin. Now what we can do, that is because of this separation techniques what we have used, the water pollution problem we are converting into the air pollution problem, and at the same time we are not able to get our lignin back. So to prevent this problem, there are new technologies developed. In the case of new technology, what we do is we use ultrafiltration, we use a nanofiltration, we use a reverse osmosis. In the case of ultrafiltration, the ultrafiltration will allow sodium hydroxide, sodium sulfate and water, whereas it prevents the passage of the lignin. So the lignin is rejected by the ultrafiltration membrane. Now the sodium hydroxide, sodium sulfate and water can be passed through the nanofiltration membrane. When you pass it through this nanofiltration membrane, sodium hydroxide and water will pass through the membrane, whereas the sodium sulfate is rejected by the membrane. Now the sodium hydroxide and water, which is coming from a nanofiltration process, is passed through a reverse osmosis process, where your sodium hydroxide will be rejected by the RO, and whereas this what do you call it, water will pass through the membrane. So by using a combination of ultrafiltration, nanofiltration and reverse osmosis, we are able to get the lignin, and this lignin can be used as a byproduct for the preparation of the adhesives, and we are going to get the sodium sulfate, we are going to get the sodium hydroxide, the sodium sulfate and sodium hydroxide sent back into the pulp and paper industry. That way there is no pollution problem, and we are able to recover the lignin, we are able to recover the your inorganics, we are able to get the pure water. So just changing the technology, instead of using a evaporation and incineration, we are using the series of membrane separation process, and that way your environment is going to be controlled. Similarly, the raw material cost is increasing day by day, the energy cost is also going to be increasing day by day. So when the raw material cost is increasing, energy cost is increasing, so one has to look at the other separation process. For example, as I told you already, the ethanol water separation process. In the case of ethanol water separation problem, we are getting around 10% of alcohol, and when you want to use ethanol for the fuel application, we need around 99.8% of ethanol. So if you want to use if you want to get a 99.8% of ethanol, what one can do, we can use the technique called the distillation. but unfortunately the ethanol and water mixture forms a azeotrope at 95.6% concentration. So we can separate up to 95.6% concentration, but for further separation we cannot use the distillation. We have a new techniques like a azeotropic distillation and extractive distillation. So when you talk about this azeotropic distillation and extractive distillation, these are the energy consuming process. So the energy costs are very, very high. So alternatively, one can think about using a membrane separation technique like a peroperation process. When use the peroperation, initially we use the distillation, then we use the peroperation process. So when you combine the distillation process with the peroperation process, the cost is going to be reduced. So increasing the raw material cost or maybe energy cost, maybe people are looking for the other separation process. This is the one of the important thing which is forcing the separation process. And customer demand for the better quality control. As I told you, everybody wants a mineral water. The quality of the mineral water is should also be good. Just to share with you one of the example, when I was traveling from Anantapur to Hyderabad by bus, and adjacent to me, the two girls were sitting. Maybe they are intermediate girls, and the bus is ready to start. And in between, by that time, one of the girl father came and asking anything else he want. That girl was saying, if you find a Kinley water bottle, get me, otherwise I don't need anything. So the customer is asking for the better quality control. That is what this separation process, when you are going to use the new separation process or any other separation process, you can meet the demand of the customer requirement. Similarly, a need for safe and flexible operating factor. And the next one is, people always look at the cost. But sometimes the cost is not only the factor, the time is the most important thing. Just to share with you one of the example, the God is so great, He has given the two kidneys. If one kidney is going to fail and other kidney is going to function, then there is no problem. But the thing is, if both the kidneys are going to fail, then what you have to do? You have to look for the kidney donors. And finding the kidney donor is very, very difficult. The reason is, earlier the government is really allowing if somebody wants to donate their kidney, but recently there is so much of restriction for donating your own kidney. The problem is here, some of the people, they are misusing just to get money. They are donating their kidney, and the maybe there are kidney thefts and other things that what you are reading in the papers. So to prevent this type of problem, today if somebody having a problem with the kidney failure cases, then what you have to do is you have to find the kidney donors. Only the blood relatives should donate the kidney, and even to donate that kidney, you have to go to the court, and you have to face a lot of legal issues. Then finally you can donate your kidney. Now, alternatively, what one can look at, we can look at the process like a hemodialysis process. In the case of hemodialysis process, we have it is another process like a membrane separation, another process in the family of membrane separation process. In the case of hemodialysis process, when the kidney is not going to function, what will happen? So there is the accumulation of creatine, there is the accumulation of urea in the blood. So when there is accumulation of creatine and there is the accumulation of urea, what you have to do is, people are using a process called as the dialysis process. In this case, what they do is, one side the blood is going to pass, impure blood is going to pass, other side the dialysate is going to pass. The dialysate basically contains the water and a low molecular weight solids like a KCl, maybe like a sodium chloride, etc., etc. So when you contact these two, that is the blood as well as impure blood as well as the dialysate with the membrane, the blood wants to move from the blood chamber to the dialysate chamber, but the pores inside the membrane will not allow the passage of the blood. The water wants to move from maybe blood side to the water side or dialysate side to the blood side. But what we do is, we maintain the same chemical potential in both the sides, so the water cannot pass us through that. Similarly, your KCl, sodium chloride, all those things, they want to move from one side to the other side, but what we do is, we prepare the dialysate in such a way that the chemical potential of the components in the dialysate is same as the chemical potential of the components in the blood side, so nothing will pass us through that. Only one thing which passes through that is urea and creatine. the membrane will allows the passage of the creatine, and the membrane will allows the passage of the urea. So the urea and creatine will pass through the membrane, it will join with the dialysate, and that way the people who are suffering with the kidney failure cases, they can use this hemodialysis process, and they can get rid of the problem of kidney failure cases. If the problem is so simple, what is the problem? The problem is, it is a problem for the rich people, it is a problem for the poor people. In the case of rich people, the time is the problem. If somebody wants to undergo the dialysis operation, the patient has to go to the hospital. Maybe 1 hour or 2 hours he has to spend. That is what we call it the pre-preparation. Then 2-3 hours the dialysis process going on. Then again after that he has to spend another 2 hours time to come back to the normal state. So he has to the patient has to spend 6 to 7 hours in the hospital, and this is a big issue for the rich people, where the time is the most important thing. Whereas for the poor people, the money is the most important thing. He cannot go to the hospital and he cannot do all these things. Whereas middle class families like us, we have a time, we have a what do you call it as the money, we can afford it. So being a chemical engineer, and one has to look at this is the one of the very interesting problem. Maybe if not now, maybe at a later stage of a time, later stage of your life. So you can look at this problem, you can solve it, and you are going to do a great service to this humankind. And to do this, what you have to do, we have to come up with this whole dialysis process. I think, I don't know whether you have seen the dialysis process or not. And when you go to the hospital, you can see the dialysis unit, which is maybe 2 times bigger than your CPU, and maybe small pumps are there in the dialysis. So what I want to tell you, this is almost size which is 2 to 3 times bigger than your CPU. But what I am telling you, if you can make your dialysis, which is the size, same size of your matchbox, maybe a cell phone, the patient can keep this dialysis unit in his pocket. Wherever he is going, it can work, and there will not be any kidney failure cases, and he need not to find any kidney donors. There will not be any legal issues and other things. So already so much of work is going on, and this is what we talk about, a biomedical instrumentation. That is the combination of a chemical engineering, electronics and instrumentation. That is where we are going to do a great service to the this is the thing. And whatever I am telling you, it's not so difficult, because there is so much of things are developing in the area of nanotechnology. One can reduce the size. If we can reduce the size, because we need some membrane unit which we can make it a small size because of the nanotechnology, and we can make some pumps, we can make some dialysate chambers, and if we can make everything like that, and the time is not too long to imagine a dialysis unit which is same size of your matchbox size. So where the cost is not only the factor, the time is the most important thing. So what I want to tell you, tomorrow's world is they expect about better, they expect about cheaper, they expect about the faster, and that is only possible with the separation process. So there is a lot of forces are impacting the separation process. So we'll have a break now, and we will start the next slide with the second lecture, and we'll continue. Thank you.